Good day. Today we will begin the new part of our discipline, the crystal chemistry. The theme of our lecture, the crystal chemistry basis, because it is necessary to introduce with them very important definition, what is it, the atomic and ionic radius. Here you can see the lecture plan, the effective radius of an atom, atomic and ionic radius, and the following regulators of the ionic radius. The difference and variety of crystalline structures depends on the chemical nature of the substance, on the size of the atoms of or ions, on the binding forces between them. There are some the base of crystal chemistry. One of them, what is the effective radius? What is it? The effective radius of an atom or ion is understood to be the radius of the sphere of its action, with the atom or ion being considered an incompressible sphere. Ionic radius. Ionic radius is the radius of a monatomic ion in an ionic crystal structure. Although neither atoms nor ions have sharp boundaries, they are sometimes treated as if they were hard spheres with radius such that the sum of ionic radii of the cation and anion gives the distance between the ions in a crystal lattice. Ionic radii are typically given in units of either picometers, pm, or angstroms, and I hope you remember that 1 angstrom is 100 pm. Typical values range from 31 pm to over 200 pm. The concept can be extended to solvated ions in liquid solutions, taking into consideration the solvation shell. Ionic radius obey the following laws. Within one vertical series of radii or ions with identical charge increases with increasing atomic number, since an increasing number of electron shells and hence the size of an atom. For the same element increases with the radius of the negative charge and the decreases with increasing positive charge, radius of anion is greater than the radius of the action anion because there is an excess of electrons and the cations and deficiency. The size of atoms and ions follow the periodicity of the table Mendeleev, exception from number 57 to 71 lantanides, where the radius does not increase and decrease, and the number 89 to 103 actinides. There is the same tendency. Ions may be larger or smaller than the natural atom depending on the ion's electric charge. When an atom loses an electron to form a cation, the other electrons are more attracted to the nucleus and the radius of the ion gets smaller. Similarly, when an electron is added to an atom forming an anion, the added electron increases the size of the electron cloud by an anti-electronic repulsion. The ionic radius is not a fixed property of a given ion, but varies with a coordination number, spin state, and other parameters. Nevertheless, ionic radius values are sufficiently transferable to allow periodic trends to be recognized. As with other types of atomic radius, ionic radius increase on descending group. Ionic size for the same atom also increases with increasing coordination number, and an ion in a high spin state will be larger than the same ion in a low spin state. In general, ionic radius decreases with increasing positive charge and increases with increasing negative charge. An anomalous ionic radius in a crystal is often a sign of significant covalent character in the bonding. Here you can see the illustration of the above trends. I have already told about that. And here the dimensions of regulators of ionic radius. We tell about that all. And here you can see that the illustration of the above trends. For example, if the ferrum, the atom radius 0.126, if ion ferrum tap 2 plus, the radius less than atom radius only 0.08, and if the ion charge increase 3 plus, ion radius in contradict decreases only 0.067. You can see that the ionic radius, if the charge of ion is positive, the ionic radius less than the atomic radius. For example, another example, element silicium. Silicium atomic radius 0.118, but if the silicium has the negative charge, the ionic radius more than atomic radius 0.1998, but if silicium has the positive charge, ionic radius less than atomic radius 0.04. This slide illustrated the trends which we tell about before.